Okay, my friends, this video is going to talk about just some nice basics to get us going. We're going to talk about variables and expressions from section 1.3 and polynomials from section 1.4. So let's just get right into it with variables and expressions. Every time I talk about variables, I always tell the same story. I was watching the show Who Wants to Be a Millionaire several years ago, and the question was something like, they gave an equation, something like 2x equals 4, and they said, what is x called? And they gave 4 options, and one of them was variable. And they said it's a variable, and then Regis said, yeah, you're correct, and they won their money. In this case, the reason that stuck out to me is this is an unknown. If you think about the word variable, just the word itself tells you that these things should vary. That x does not vary. It doesn't change. It equals 2. In the sentence that I wrote, in the equation I wrote, you don't know what it is. It's unknown, but quickly you can figure out that it's 2 and it stays at 2. So a variable is something that changes, and it's part of an expression. I can give you, so here's my non-example of a variable. I could give you the expression 2x squared plus 4. Now x is a variable because I haven't put an equal sign. The equal sign is what restricts it and makes it an unknown. But here, x can be whatever I want. I can say let x be 0 and plug that in. I could say let x be 1. I could say let x be 2.37. I can let x be anything I want. I can vary it. And I would plug those values in for x to see what I got. So that's just some technicality stuff to get us started. Expressions, basically it's just a mathematical sentence, and it's not an equation. A lot of times we will say that something's an equation when it's not. Technically, according to our book, an expression is a collection of variables and constants connected by operation signs, plus, minus, multiply, divide, etc., which stands for a number. So this 2x squared plus 4, that's an expression. 3x cubed minus 2x squared plus 11x plus 6, that's an expression. The square root of 3x is an expression. There are lots of expressions. It's just once the equal sign gets into it, that's when it's an equation. You could say, hey, what's this? And the average person will say, that's an equation. If they see math, they think that's what we do in math. We do equations. But that's an expression, no equal sign. Okay, so this is just some background info. The skills you're going to need, actually one more background. Absolute value, you probably already know that this always results in a positive value. The definition of absolute value can be kind of tricky. The way it's listed, the absolute value is x of x is x if x is positive, or if x is greater than or equal to 0. The absolute value of x equals negative x if x is less than 0. That can be confusing if you see that in print, because you see this and think, wait a second, the absolute values are always supposed to give me positive results. But think of this as the opposite. If your x is negative 4, then the absolute value of that is positive 4, which is negative 4, or the opposite of negative 4. So don't see that and think you've been incorrect about absolute values your whole life. You are correct. It always is positive. But that's more, that negative sign stands for opposite of, rather than a negative value. Okay, so like I was saying, skills you're going to need to know in this section, which I think you probably already have, are order of operations and summing in values. And I'll just do a quick example because we don't need to dedicate too much time. And by the way, if this is your first flip video, I'm going to keep these as basic as I can. Just write down what you see, pay attention, and bring that into class with you. And that's it. So I'll try to pick one that has at least some intrigue. This is 17 from this section. The absolute value of 8 minus 5x minus 2. And our instructions are to let x be 2 and let x be negative 3. Okay, so this is just subbing in, again, this is an expression, it's not an equation. You sub in 2, you get the absolute value of 8 minus 5 times 2, and this will bring in our order of operations. So we've got 8 minus the multiplication of x first, that's 10, that's absolute value of negative 2, minus 2, that's 2 times 2, that's 2. You show a couple steps. You don't have to show every step that is going on, because a lot of these steps you can do in your head. The next one, 8 minus 5 times negative 3, that's 8 minus negative 15. So it's negative is positive, 8 plus 15 is 23 minus 2, 21, I believe. Been known to get some figuring wrong in my head, but I think that one's good. So 0 and 21. So this section, that really wraps it up. There's some distributing in there, there's order of operations, like I said, but nothing you really need to worry too much about. Alright, so let's turn the page here, and let's talk about polynomials. A little bit color. Okay, so 1.4 is on polynomials. Alright, what's important to us about polynomials? First of all, what is a polynomial? Again, with the technical definition of polynomials, an algebraic expression that involves only the operations of addition, subtraction, and multiplication of variables. So, some examples. 11x squared plus 2x minus 6. This is a polynomial. X is a polynomial. X squared y to the 4th, z to the 21st. Polynomial. Okay, you can have more than one variable, but we only have addition, subtraction, multiplication of those variables. We cannot divide by variables. So, non-examples. 1 over x, not a polynomial. Alright, if the variable is in the denominator, not a polynomial. Square root of x, again, absolute value of x plus 3. All of those things, the dividing, the square rooting, and the absolute valuing, those exclude this from being part of polynomials. Okay, you could have something like square root of 3 times x. That is okay, because the square root doesn't have the x underneath it. So what are they going to ask us about polynomials? We're going to classify or name polynomials in this section with 2 rules. First rule is by number of terms. Okay, a one-term polynomial is called a monomial. Alright, 4 is a monomial. X is a monomial. X squared y to the 4th z to the 21st is a monomial. Alright, we don't have any plus or minus signs in this. It's have one term. It might have multiple letters, it might have exponents, but we just have one term. Basically, terms are separated by plus and minus signs. Binomial. A few examples. A binomial is basically going to be 2 plus x, or 3zpq plus 2z squared. 2 terms, 1 plus or minus sign. A binomial, bi is for 2. 3 is trinomial. And you can come up with an example there. You're going to have 2 plus or minus signs. 4 or more, we don't have a name for those. So if you have a quiz question that says, name this, and it's got 4 terms or more, you can say 4-term polynomial or 5-term polynomial. That'll be fine. But 1, 2, or 3, you will be expected to know monomial, binomial, trinomial. Alright, so now let's talk about degree. The degree of a polynomial, the degree of each individual term is basically how many variables are in that term. So the term 2x squared has a degree of 2. because I have two x's in it, and I realize I can only see one x, but I have two x's because of the square. 2xy, degree of 2. Degree of 3 could be something like 3x to the third. It could be 3xy squared. It could be 3xyz. All of these, the degree equals 3 because there are 3 variables total. Now, if you want to know the degree of the entire polynomial, you go to the term that has the most, okay? So 4x to the fourth plus 3x cubed plus 2x squared plus 1x plus 10. The degree of this polynomial is 4 because the term with the most has a degree of 4. So this would be a fourth degree, 1, 2, 3, 4, 5-term polynomial. Okay, so count the letters, including the repetitions of the exponents. Count the letters, and whichever term has the most, that's the degree for the whole thing. So what's the degree of this? Okay, so we're counting up the degree of each term. The degree of my first term, which is here, is 4 plus 7 is 11, 12. This has 13. Here we have another 13. I mean, for that to happen, but that's okay. And here we have 6. A lot of people will say 4 for that last one, but the single instance of the y and the z do count toward the degree. So what's the degree of this polynomial? 13. This is a 13th degree trinomial. So we've got some names for these as well. Up through, let's see, 5th degree, we're going to name these. All right, a 0 degree is called a constant. Think of an example of that. How about 4? It's a constant. A first degree is called linear, like 2x. All right, one variable, one letter. Constant has 0 letters in it. We have quadratic. If we're in the quadratic formula, quad sometimes sounds like 4, but in this case 2. Second degree is quadratic. Cubic, quartic. I definitely spelled that wrong. Quar, USC, and quintic. And as it says in the chart in your book, 6th or more, we don't have any name. So if it's 6th degree or higher and you're asked to name it, you could say 6th degree. All right, so make sure you have those down. We want to name by number of terms and by degree. So I could say, for instance, this is a quadratic trinomial, or a cubic 5-term polynomial. And that is pretty much the skills that are going to go along with this section. All right? So that will do it for sections 1, 3, and 1, 4. Young out.